We're going to do number 4 together. All right, it's got 3 parts. So if you look at this, it's giving you the graph of f from -4 until +4. They're telling you that there are horizontal tangents at x equals -1/2. So I'll put those there for you if you want. So x equals -1/2, x equals +1/2, and x equals 5/2. All right, so 2.5. This the last piece between 1 and 4 is a parabola. They've given you the actual function there. And the regions A and B that are listed are the areas in there are 3 and 5 respectively. Okay. They're also telling you there's a g of x function that is equal to the integral from -4 to whatever x you're evaluating for that of f of t times dt. All right, you guys ready? All right, let's do g of 0. All right, so I'm going to just use the last piece they just gave us. I'm going to write down g of 0 equals the integral from -4 to 0 of f of t dt. All right. So remember an integral. I think we talked about this yesterday. All right. When you see that integral, what is that telling you to find? Yeah, you're not going to do that here. You don't know the information. Do you remember like the 2 main questions of calculus? What is the integral calculus asking you to find? This is like a big thing. The area under the curve. That's it, right? I mean, that's like if somebody says, hey, what's calculus like? Area under the curve. All right, that's it. That's calculus. Okay, so look at -4 to 0. I'm focused on -4 to 0. What do you notice about -4 to 1? Or excuse me, -4 to -1? It's a triangle. Do you know how to find the area of a triangle? Oh my gosh. All right, so we have a triangle, which is, what's this base? 3. Excellent. Sad, Andrew. What's the height? 3. All right. So what's the area of this triangle? Great. Excellent. Okay. Times half. What's not divided by half? 9 times a half or divided by 2? Just say 9 halves. Excellent. 9 halves. We did it. All right. Now, that obviously is not the full answer because did I get to 0? No, that's only -4 to -1. So I also have to include this area from -1 to 0. And what do you notice about that area? It's negative. See how it has negative y values? So that area is going to be negative. So that means I need to subtract this area. The problem told us what A is equal to. All right, what is the area for A? How many units? It says A is 3 units, right? So I'm going to do 9 halves minus 3. Okay, can you rewrite 3 with a denominator of 2? What is it? 6 halves? Oh, not equal, sorry about that. All right, so what is our answer? 3 halves. Or as a decimal, 1.5, your choice. Questions on the first part of part A? Did you get that, Jennifer? Joelle, you were talking about it, right? No, those giggles are no giggles? Okay. Let's try the next one. G of 4, which says the integral from, let me write this up here because I think this is going to be more work. The integral from -4 to 4 of f of t dt. Now, we already found some of it, right? All right, we just found -4 to 0. I'll break it up into the first pieces. So we have 9 halves minus 3. Yes. What's the next piece? What's letter B? Do you remember the next piece here? Letter B? Is it 5, right? And see how the y values are above the x-axis? So I'm going to do plus 5. Okay. All right. And then the last part is to find this area. All right. Do you guys see that area? All right. How are they describing that area? They actually gave us a function, right? Yes. Do you see this function? So I need to find plus the integral of, which one is that? 1 to 4? 1 to 4 of negative x squared plus 5x minus 4. How's everybody doing? Everyone okay? No, Michael, you're not okay? I can answer questions if you're not understanding. Okay, all right. All right, so really I'm going to focus all my work now on this integral. So now I think, Andrew, you said it when I asked about the integral. You said the antiderivative. So let's find it. Thank you. What's the antiderivative of negative x squared? Negative 1/3 x cubed. What about the antiderivative of 5x? You know it's got to be x squared, right? Okay. Nice. What is it, Denny? 5/2. Awesome. Use that reciprocal. Okay. And then minus 4x. Excellent. So I'm going to evaluate this, right? Put my bar. My limits of integration are 4 and 1. So now I need to do negative 1/3 times 4 cubed plus 5/2 times 4 squared minus 4 times 4, right? All of that is going to be one thing, right? Minus, now do it again, but for positive 1. Remember, this is not a calculator question, so we're going to have to do this in our heads. I'm sorry. Mr. Dragna said he's proctoring your AP Calculus exam. All right. What is that? What does it matter? Oh my gosh, I thought that'd be a good thing, right? A science teacher? Sorry. Why is he going to be sad? Bro, I'm recording, man. I'll have to snip that out. Okay. Yeah, where you guys all booed him? Jeez Louise. You guys are harsh. I can't even imagine what you say about everyone else. Okay. You ready? 4 cubed. 4 cubed. 64. Excellent. So that's going to be negative 64/3 plus 4 squared. 16 divided by 2. Yay, 1. 16 divided by 2. 8. Hey, 1. I'm here. Good to see you. 8 times 5. 40. Minus 4 times 4. 16. Okay, let's go over here. How did I get 40? I lost you. 4 squared. 16. You could do 16 times 5 divided by 2, but I did 16 divided by 2, which is 8. 8 times 5 is 40. Okay, 1 cubed. 1, so that's going to be negative 1/3 plus, your excuse, 1 squared is 1 times 5/2 is 5/2 minus 4. Guys, you ready for this? Okay, let's keep going. Let's get a common denominator over here. What is 40 times 3? 120. 16 times 3? Okay. And then let's do that. Negative 64 plus 120. Was that 56 thirds? And then 56 thirds minus 48 thirds. Is that 8 thirds? Yeah? We'll find out at the end. I know the answer, so we'll see if we did it right now. Okay, minus, let's get a common denominator here. What's that going to be? 6, so negative 2/6 plus, what's that, 15/6 minus, nope, that ain't it, 24/6. If I make a mistake, please tell me. Let's see, so that's going to be 13/6, negative 9/6. One more common denominator. What's that, 16/6? 25/6? Oh, I feel like I made a mistake. Anybody? Did I make a mistake? Yeah, so okay. Okay. What'd I do? Did I go up more? Andrew. Well, we'll find out once we do the whole thing. Now, is that the answer? No. Right? That was a lot of work. That's not the answer. That just slots in, right, into this 9/2 minus 3 plus 5 plus 25/6. So let's go to the common denominator 6. So that's going to be 27/6 minus 18/6 plus 36 plus 25/6. Okay, 27 minus 18, 9. 9 plus 30, 39. 39 plus 25. I did something wrong. No? No, I did something. Yeah. Is that it? What did I do wrong? I'm going to figure it out at some point. 9, 39. It's 54/6, right? I think it's supposed to be 66/6. I did something wrong. Isn't it supposed to be 66/6? Did I add wrong? Israel, tell me, Israel. It's 64? That's also wrong. Hold on, let's find it. All right. Everybody good, right? People watching this are like, whoa, what just happened? Yep, got the right answer. Excellent. It was magic. You know, it's amazing that you can do all the calculus right and then not subtract 24 minus 13. Oh, if only I could use a calculator. Okay. Questions on A. No, everybody good? Awesome. That was just A. Let's go to B. Find the absolute minimum value of G on the closed interval -4 to 4. Before we get into like the specifics of finding it for this problem, do you know how we figured out absolute minimums or maximums on closed intervals? Do you remember the process, the steps we had to do? Okay. Step 1 was find the derivative. You know step 2? No, no, I know. That's the tangent line. I'm sorry. Do you remember what happened after you found this derivative? Set it equal to 0. Okay, and what happens when I find what values make that derivative 0? Do you remember what those are called? Those are called zeros. Yes, I mean, there are zeros. There's something in calculus stuff. It's okay. We still have many days till the exam. They're called critical points. Okay, and those are the critical points you're going to try. You're going to put those into the original function to see which one is your largest y value. That'd be the absolute maximum. And then you do the same thing and see which one is your lowest one. That's your absolute minimum. The one thing that students sometimes forget is you do need to also plug in the boundary. Right? If it says over closed interval, make sure you plug in those two as well. Right? Because it could be one of those. Right? They might be the actual absolute minimum or maximum. So the thing you need to recognize when you read this, I know there's a lot of reading going on, but if you look at what they told us about g of x, so this very last thing, do you see what it says g of x is equal to? It's equal to the integral of f of x. So with that being said, what if I asked you to find g prime of x, so the derivative of g of x? Do you remember what happens when you take the derivative of an antiderivative? Fundamental theorem of calculus part 1. Yeah, okay. That's what? It's just the what? It's just a function, just the f of x. So this right here is kind of the understanding you need to answer part B. That the g of x function is the the g prime of x function is the f of x. So what did they give us in the very beginning here? They gave us the graph of f, which in other words, this is the same as g prime of x. All right, so step one is to find the derivative. Do we know the derivative? No, but we do have a graph of it. So what was step two? Find what makes the derivative 0. So Michael, when you said zeros, what are the zeros of this function? I'll erase all my kind of work there. What are the zeros here? Where does this graph of f hit the x-axis? -4, -1, 0, 1, and 4. So those are called our critical points. So the critical points are -4, -1, 0, 1, and 4. All right. So if we had all the information here, we could plug in these values into the g of x function. All right, but we're just going to use the graph. Okay. Think about when we talked about maximums and minimums. All right. If you were to sketch something that is an absolute minimum, that means watch what happens to the graph, right? You're going to be going what? Decreasing to increasing, right? That would be the absolute minimum. All right. So I want to look here where I have decreasing to increasing on this function, on this graph, all right? So I want to look at where my values, all right, are going from, right, positives to negatives, all right, positives to negatives here. So look at -4, okay? I'm sorry, did I say positive? I meant negative positive. Let me try that again. Let me do a sketch. Okay, so here is an example of an absolute minimum, right? So if you look at this curve that I just drew, we're decreasing to then increasing. So on this sketch, I want to be looking for negative values going to positive values. Okay, I'll repeat that. Negative values going to positive values, because that would mean that that is where our function is decreasing to increasing. So look at the very beginning. What's happening in -4? Right? We have positive values from -4 to the right. All right. I don't know what's happening over here. Could this be over here? Could it be like that? It could, right? But it also could be up here. I don't know. All right. So that's an option. Let's go to -1. What's happening in -1? It's positive y values, right? Positive y values to negative y values. Okay. So that means it's increasing to decreasing. Is that what I want? Increasing to decreasing? I want the other way around. So -1 is not going to be an answer. All right. If this problem had said, find the absolute maximum, right? If this keyword had changed to maximum, could -1 be the answer? Yes, it could be the answer, but not for this, not for minimum. Let's do 0. Okay. What's happening with 0? So negative values to positive values. So that means we're going to be decreasing to increasing. Is that what I want? Decreasing to increasing? Yes. So could 0 be it? Yes. So far it could be -4 or 0. Let's try 1. What's happening with 1? Just positive values, right? So not going to be 1. And then let's try 4. Okay. What's happening at 4? Going from positive to I don't know, right? Could be negative, could be back to positive, but that's not what I want because I want it to be negative first, decreasing first. So not 4. So the only options are -4 and 0. All right, so we need to evaluate these. So g of -4 and g of 0. Didn't we already calculate one of these in part A? Which one did we calculate in part A? G of 0. And what was g of 0? 3/2. All right, so let's do g of -4. So that's -4 to -4 of your f of t function. Let's see if you guys remember a property about integrals. Do you remember what your value for the definite integral is equal to if your limits of integration are the same? Sure. Do you see how, Natalie, the limits of integration are the same? There's a value that any integral, no matter what this is, if these limits of integration are the same, it's always equal to a number. No. It's 0, right? Because in order for there to be area under the curve, we have to move to another number, right, Michael? So if we're not moving to another number, it's going to be 0. So this is 0. Look at those two y values. Do you see the two y values? One's 0, one's 3/2. Which one is smaller? 0 is smaller. So what is the absolute minimum on this interval? -4, 0. The absolute minimum is okay. Key takeaway is remember the steps to find those critical points. All right, let's do the last one. Part C. All right, we talked about this. Boys may not have been here, so I'm sorry if you weren't here, but I'm sure you've watched the videos, right, for the stuff you missed. We talked about things being concave up or concave down. Do you remember how to figure out if your function has pieces that are concave up or concave down? Where do you go to find that? The second derivative. So it's like the exact same process. Find the derivative, second equals 0 to get your critical points. But instead of finding the first derivative, you're finding the second derivative. So, all right, let's find the second derivative. Let me rewrite what I wrote earlier. So g of x, what did I write? I wrote g prime of x, is equal to f of x, right? So what would be g double prime? F prime. Interesting. Okay. So if I look at this from the graph of f that they gave me, if I find the derivative as I go on that graph, that function that they gave me, I could figure out what's going on with my second derivative. Okay? So let's go to the graph. All right. So what do you notice about these values here when I take the derivative? You remember how to do that? Right? I think I used orange a lot, sometimes pink. All right, take the derivative is you find the tangent line. What do you notice about that tangent line? It's constant, right? So what's going to be this value here? Constant, what type of number? I don't need to know the exact number. Positive, right? So positive there means what about our function? If the second derivative is positive, what does that tell us about our original function? It's concave up. What does the question say? Where's the concave down? So am I going to be writing -4? What would be better? Should I do the work? I went too far. Do you want me to do the work here next to the graph or in the spot? Next to the graph, then you just copy down in the spot, okay? All right. So we said from -4 until -2, it's concave up, right? Everybody see that? Okay, now what happens when you get past -2? What do you notice about this? It's negative, right? If it's a negative slope there, that means that your second derivative is negative. So that means the original function is going to be concave down. It's going to be concave down. Now watch what happens. It's still concave down here, right? It's still concave down here. When does it turn to be concave up? Say it again. Question you said? It is close. -0.5, right? Right? Because we're on the negative side. All right. Do you remember? Oh man, I'd be really impressed if you got this right. Do you remember what that point is called when you go from concave up to concave down or vice versa? What up, Michael? Awesome. So good. All right. So we have -2 to negative, what'd you say? Let's see if I know you said -0.5. So that's concave. What'd you just tell him? What'd you just say? What'd you tell him?
Oh, he said he'd do it, but he didn't say it.
Just gotta speak up.
Well, I know Michael likes
the attention. Totally understand. Totally get it. So good. All right. So now, what did you just do? What'd you just do? Okay, have a nice brotherly pat. Okay. Now we're going to be concave up. What's up, Jennifer? Do you need to answer a question? Okay. So now we're concave up right here until we get to another point of inflection, right? So from negative 0.5 until 0.5. Concave up for this one. Now we're back to concave down until 1. Remember, you should be writing this in part C. It's okay. And then here we're back to concave up from 1 until there's another point of inflection. What's that, 2.5? And finally, we're concave down to finish. All right, so in terms of answering part C, and I think, was it Jennifer or somebody, Joel, maybe you asked about this, about sentences. I would write a sentence here. I would say the g of x function is concave down in the intervals, and then I would write these intervals. I'll write that right now. Okay, which one is it? We've got -2 to -0.5. Then we have 0.5 to 1. And is it 2.5 to 4? Excellent, thank you. And that is it, guys. That's question number 4.